The topic of this video will be on scaled drawings and proportions. So let's first start with talking about something called scaled copies. So this definition here says that a scaled copy is just an image of a figure with accurate sizes that are either reduced or enlarged by a certain amount, called the scale. So we've seen this already, and we've had some exposure to images that are scaled either by being reduced or enlarged. So please note this sentence right here. This says, and I'm highlighting it in blue, remember that when a scale factor is not given, you'll need to compare the corresponding parts of the figures in a pair of scaled copies in order to compute or calculate that scale factor. Now the key word I want to highlight is corresponding. We haven't seen that word since last semester, but you should remember what that word means. Corresponding is referring to sides that match up in two different shapes. So what I mean by this is, let's take a look at these two examples here. Number one says these two triangles are scaled copies of each other. Okay, so we're given that this triangle has been scaled and it actually has been reduced to get from this triangle to the next triangle. I'll call this triangle A, and I will call the smaller triangle B. So if I scale triangle A, I reduce it and I get triangle B. Now notice they did not tell us what the scale factor was. All they did was give us two shapes that, and we're given that they are scaled copies, and we have a few of their dimensions, but we don't know much else. We don't know what the scale factor is. So what I mean by corresponding parts, I mean look for the parts that'll match up. So for instance, this left side of the triangle matches with this left side of the smaller triangle. However, I don't have a measurement in triangle A that I can match up with in triangle B. The bottom side in triangle A matches up with this bottom side in triangle B. However, I only have measurements in triangle A. I don't have a measurement in triangle B. Now the last pair of corresponding parts are these blue sides, and I do have numbers for triangle A on this side and a number for triangle B. So I'm going to use that pair, and I'm basically going to say if I took 12 on triangle A and I multiplied that with a number, I don't know what the number is though, so I'll call that number X, my result in triangle B is the number 9. So I can use this to now find what the scale factor is, and that scale factor is represented by that variable X. So dividing both sides by 12, I get that my scale factor is 9 divided by 12. Using my calculator, 9 divided by 12 is 0.75. Remember, if you convert that to a fraction, it's 3/4. So whichever one you prefer, remember we can represent scale factors either as decimals or fractions. I'm going to just call this 0.75 because that'll be easier to work with. Oops. So essentially what I'm saying is take all of the sides in triangle A, multiply them by this scale factor, which is 0.75, and you will get the resulting dimensions in triangle B. So let's do the green side. If I have 16 on this side, I want to know what the corresponding side would be in triangle B. So I'm going to take 16, multiply it with 0.75, and I get a result of 12. So that means that this green side on triangle B is 12. And the last side that I need to figure out is this yellow side on triangle A. So I need to think, well, what number times 0.75 will give me 6? So I have to think backwards now, and I have to think, okay, well, what is 6 divided by 0.75? And that's going to give me 8, and that would be the missing side. And if you want to check to make sure this is right, you could say, well, what is 8 multiplied by 0.75? And that gives me 6. So that is, in fact, correct. So now I've used the corresponding sides to find my scale factor, and that helped me fill in all of the missing sides for both shapes in this pair of scaled figures. Looking at number 2, I'll highlight one more time the corresponding parts. So we have this side corresponding with this side. We have this blue side corresponding with this blue side in the smaller triangle. And we have this yellow side corresponding with this yellow side. Again, we have one triangle on the left being reduced to be a smaller triangle on the right. See if you can figure out which pair of sides you would use to calculate your scale factor, and then fill in the missing sides. I want you to hit pause on this video, try and do this on your own, and when you are done, go ahead and press play again to check your answer. So press pause now. Okay, so you should have used the green sides to figure out your scale factor, and you should have said 24 times what number gives you 16. And your scale factor came out to be 2/3. I wrote it this time as a fraction. So now to find the missing sides, you should have taken, let's do the yellow sides. Let's take 18 and let's multiply that with, in parentheses, 2/3. So pay attention to how I put this in my calculator. Notation is very important. Hitting enter, that gives me 12. So that means the yellow side is 12. And then the blue part, now you have to think, well, what number times 2/3 gives me 14? So you have to kind of think backwards here. So you could do 14 in this case divided by 2/3. And that gives you 21. And again, just to double check, if I take 21 and multiply that by 4/3, I should get, I'm sorry, not 4/3. Take 21 and multiply that by 2/3, I should get the resulting side on the smaller triangle, which is 14, and I did. Now for these next examples, let's read this sentence here. It says, sometimes we will need to determine whether or not pairs of shapes are in fact scaled copies of one another. So in examples 1 and 2, we were told those two triangles were scaled copies. But for numbers 3 and 4, we don't know if they are scaled copies, and that's for us to figure out. So again, corresponding parts is going to be really important here. So I see that this side that is 7 corresponds with this side that's 3.5. And then this side that is 4 corresponds with this side that is 2. So the way that I can see if these are in fact scaled copies of one another is I can basically set up a ratio. So I'm going to say the 7 on the bigger rectangle corresponds with the 3.5 on the smaller rectangle. And I want to know if that is equal to the ratio for the other two sides that correspond. So if I had the bigger triangle's dimension on the top for this fraction, I have to have the bigger triangle's dimension on the top for the other fraction. So if 7 corresponds with 3.5, I also want to know if 4 corresponds with 2. So I need to just compute and see, are these two fractions equal? So if I do 7 divided by 3.5, I get 2. And 4 divided by 2 is 2. So because the two corresponding ratios are equal to one another, we can conclude that yes, these two shapes are scaled factors of one another. For number 4, let's look at this side of the triangle that corresponds with this side on the triangle. And then let's look at this bottom side corresponding with this bottom side. So the ratio we could set up here is 14 on the big triangle corresponding with 4 on the smaller triangle equal to the 6 on the bigger triangle that corresponds with the 2 on the smaller triangle. So 14 divided by 4 gives me 3.5. And I want to know, is that equal to 6 divided by 2, which is 3? And the answer to that is no. So because the proportions, or because of the ratios of the two corresponding parts on these two triangles were not the same, we cannot say that these two triangles are scaled copies. This triangle, this smaller triangle here, is not an accurate copy of this bigger triangle. Number 5 asks, is triangle UTV a scaled copy of triangle KJL? So this one I want to save for you to discuss with your groups. I think it's a very interesting problem. One thing I will tell you and warn you about is we were talking earlier up above about corresponding parts. And it was really nice in these examples. All of the shapes were oriented the same way. However, in this example, look at the matching angles, the double arced angles and then the single arced angles. They're in different spots, therefore meaning to get from this triangle to the next triangle, you not only scaled it, or maybe you scaled it, but you also rotated it. So please keep in mind when you're setting up your proportion or when you're setting up your ratios that you find the corresponding parts and then you can see if they're equal or not. So right now go ahead and press pause on your video and discuss with your groups. Is this triangle on the left a scaled copy of the triangle on the right? Make sure you explain why or why not. Okay, so after you've discussed the front, I want you to now move to the back side, and I want to do a little bit of skill building. And I want to skill build with solving proportions. So I want to define what proportions are. A proportion is basically a statement that says two ratios are equal. And you might have seen proportions before, but the reason proportions are really important is because what ratios are, this word ratio, ratios are basically scale factors, because scale factors, as you see, or as you saw in the page prior, scale factors are basically a ratio of two measurements. So remember when we had set up these two fractions and we had to see if they were equal to one another, that's essentially what you're doing when you're finding scale factors and determining the scale factors of two shapes. So solving proportions is a really important skill. Just like lifting weights helps you become stronger and make you more able to do the things you want to do, building skills in these such as solving proportions are going to help you become more efficient and solve more interesting problems, and ultimately, especially with your inflatables project. So I just really want you to practice this skill on the back. I'll do a few with you. I can probably have time to do one, and then I'll save the rest for you to do in your groups. But essentially, the main idea with solving proportions is, you just want to multiply across. So you just want to take your 4 and multiply that with the 21. And then you want to set that equal to the x multiplied with 3. So writing that out, I would say 4 times 21 is equal to x times 3. And 4 times 21 is 84. X times 3 is 3x. Dividing both sides by 3. 84 divided by 3 is 28, and x is 28, and you have solved the proportion. So solve the rest on this page and I will come around to answer any questions that you have.